Thank you all for attending. Today's webinar will be on a new model for high-performance computing adoption in the higher education marketplace. We are proud to share with you our mix between experience and innovation with our presented content. Each webinar covered a different topic that we believe will be relevant to your day-to-day experience, your strategic planning and operations, as well as your cost effectiveness. We have hosted webinars with multiple topics, including about data center sourcing and economic strategies or effective operations of a data center. You can find our recorded content when visiting the shown link, www.eypmcfinc.com/video. Also, don't forget to follow us on LinkedIn. Before we start, if you have questions, please feel free to write them down in the chat room, and we will be answering at the end of this presentation. We would like to welcome our speakers, Kevin Sanders and Raul Martinek. Raul joined DataBank in June of 2017 as the Chief Executive Officer. He provides overall strategic direction of the company and its operations. Raul is a 20-plus year veteran in the telecom and internet infrastructure sector. He most recently served as a senior advisor for Digital Bridge Holdings. He also served as a chief executive officer for New Jersey-based data center and managed service operator NetAccess. Prior to NetAccess, Raul was the CEO of Voxel.net, a global managed hosting and cloud company. Raul has a broad experience, including roles like chief restructuring officer for a large Ireland-based fiber carrier, or working as a telecommunication and internet senior advisor for a $4 billion hedge fund. Raul, it is a great honor to have you as our guest speaker. Our other speaker is Kevin Sanders. Kevin is EYP's managing principal for data center consulting and strategy. Kevin has over 35 years of experience in the planning, design, implementation, and management of data centers, information systems, and network and communication systems. As a consultant for the past 25 years, he has worked with many colleges and research universities, healthcare, pharmaceutical, and financial institutions, including from the Fortune 100 list. Kevin is responsible for all client strategic data center consulting work for EYP Mission Critical Facilities. Thank you, Kevin. Please proceed.
Thank you, David. I appreciate it. Thanks, everyone, for joining this afternoon. I hope this is going to be, fun for you. And I want to make a point of noting that this is the first in a series that we're going to have in higher ed, mostly focusing on high-performance computing. I use the term HPC as a shortened version for those of you who have played in this space. What we're trying to do here is to talk about differing solutions and discuss different use cases and present you some leaders and leadership in innovation for the HPC community. There is some spillover to the sort of regular administrative and academic also, but a lot of the focus in particular today is going to be on high performance computing. We intend in the future to have other solution providers on board. We have some white papers that are going to be delivered by members of our college and university partners, and EYP ourselves. We're going to be presenting several white papers that talk about some of the economics and some of the design options in high performance computing. Today, I am going to spend a little bit of time at a fairly high level talking generically about master planning and high performance computing, and there's a real reason, and we'll get into that in a few minutes, of why I think this is an important issue. Raul is going to talk about an incredibly unique solution capability, and I think that what typically happens when institutions are looking at overhauling their infrastructures, particularly to HPC, they tend to go down the same wagon path of either build or remediate their existing facilities. And we asked Raul to be our first speaker because of the sort of uniqueness and the opportunity that his solution provides. And more importantly, because this is the edu community, we strongly invite you to offer topics. If you'd like to do a presentation yourself, to please contact us and we'll talk about it. And ultimately, we'd like this to be a sort of a forum for exchanging viewpoints and solution sets between our members. Trying to advance the slide here. There we go. So just a little context, because context is sort of everything in life. You know, when I like to talk about the work that we do as part of the sort of continuum that EYP represents to its client community. So as David indicated, I manage the strategy group, and we produce short, medium, and long-range strategies for both higher education, college and universities, and for commercial and governmental clients. But one of the reasons why we're able to do that is the fact that the back end of the company is also an engineering, design, and implementation, commissioning group. And strategies are fueled by two pieces of information. They're fueled by the data which the client themselves can produce for us in analyzing their needs. And then there's this collateral information which is required in order to produce a really solid strategy. And having the ability to understand design and engineering and implementation costs for data centers allows us to develop strategies that are, again, fairly unique, a little more accurate and a little more insightful than most of our clients can do on their own without the kind of engineering support that we can bring. So since most of you are in HPC to start with, it's always dangerous talking about a list of things that is driving the expansion of HPC. But there are a few items that I want to point out that are extremely common across the board. I hate using the term, but it works. It's sort of Moore's law on steroids. If you look at the cost for high-performance computing hardware, bare metal, in the last couple of years, it has begun to drop precipitously, and that's really a good thing. That allows folks to refresh. Moving from cycles that may take 5, 6, 7, 8 years in some instances to replace their hardware, down to sort of intermediate cycles of 3 to 4 years perhaps before they rebuild. And there's an ever-increasing value, incidentally, in that hardware also provided by many of the major manufacturers. Huge increase in the software tools to allow analytics, and this sort of topic I like to rant about the democratization of HPC. And I begin to think that the sort of elan status of HPC begins to fade a little bit in this modern era because everybody is doing it. Everybody wants to have the ability to analyze and gain insights from really very, very massive data sets. Artificial intelligence is beating us up on the head. Rise in GPU computing, you all know this. But even some sort of less obvious issues like self-driving cars. We have a client who is one of the largest global auto manufacturers, and for many years we've supported their HPC implementations in areas that were, understandable. They were the, design and engineering of their cars, and in the last couple of years, we've been working with them to develop these very, very large high-performance centers to be able to have them develop their self-driving car and their operations and maintenance around that for these large fleets that they intend to launch in the next several years. And so that's an entire area of high-performance computing on the commercial side that, that didn't happen. Hybrid cloud, most of you have probably explored the use of cloud. We'll talk about that in a minute. That in the world of HPC is somewhat new. And so there's this whole feeling that high-performance computing is now becoming more of a mainstream capability or requirement, particularly in education, than it ever used to be. Slow network, folks. Sorry. David, I'm having trouble having this advance.
I can help you. What slide? I moved the next slide, which is hide education
There you go.
strategy.
Thank you. So we, over many years, we have sort of discovered this list or this area of issues which are not technical issues, which we find that are very common to a lot of HPC environments in higher ed. Not all of these things exist with every client. Almost all of, there's at least one or two in every institution we run into. But interestingly enough, these issues become the problems in expanding and consolidating HPC within higher ed. And so, they're sort of pet peeves of mine. The one I think that we all come up against is that HPC pretty much grew in stovepipes within given departments. Chemistry, physics, biology, mathematics. Everyone developed their own HPC capabilities. There certainly has been some merging in the last few years. Some institutions are way ahead of this and have consolidated, but it continues to be an issue, and it goes to this whole concept of master planning and sort of denying a collective or group benefit. Budgets, for instance, and how costs are allocated at the higher ed level, they're generally done in stovepipes. And in many instances, one of the things that we run across is that, projects are launched to fix existing infrastructure rather than talking about sort of large-scale modernization, what I call patch on patch, where we have, 1,000 square foot or 500 square foot room, and we, we tend to try and keep it alive over many years, and we keep shoehorning in equipment in greater density, and it just doesn't really work particularly well. I often find that what that does is it puts grant work at the mercy of some fairly poor capabilities, or it drives the costs up when you're competing for grants. And oftentimes there's this focus on technology, on the HPC hardware itself, and not necessarily on what would be looked at as an executable plan. How do I get this in here? How do I consolidate? How do we pool all of our resources? But despite all of that, I'm constantly amazed at how successful most institutions are at keeping themselves alive, and unfortunately a lot of it is by brute force. Next slide. So I tend to look at their four major challenges in HPC, and aging infrastructure is we all understand. Now, again, not common to all institutions. Some of you have rebuilt. Some of you have done some fairly good remediation. But again, today, one of the things that we want to talk about is a way to handle aging infrastructure, looking at sort of custom design development that gives you a sort of a different approach to the typical on-campus rebuild a particular room in a building that's been there for some period of time, or just moving out to a co-location facility, off campus, because that seems to be the way to go. There is this sort of reticence for large-scale data center consolidation. I think that that's probably evaporating quickly. I think a lot of institutions are realizing that they've got to increase their resiliency. They want to meet environmental goals, and a lot of the existing HPC rooms just simply aren't efficient. And there is an interest in overlapping with non-HPC in many instances, depending upon how large data center consolidation is required. And that gets into the point of, yes, you can develop a new facility and you can segment HPC from, standard computing, academic and administrative computing, and keep them isolated while sharing in the benefits of a new facility if you plan it correctly. The cloud does really well in SaaS, in higher ed, but it's been slow to be adopted in the HPC portfolio, although using it as a back end and bursting to the cloud for some HPC applications is in fact very popular. But it's very difficult theoretically to assume that all of your work is going to go to the to a cloud environment. Because it becomes very costly. Most of the economics that I've seen for folks who've tried it usually are a 1.5 to 2x increase in cost if you do it large scale. I know that is falling very quickly. I know that's going to turn around rapidly in the next couple of years, but right now it can be difficult to push everything to the cloud and maintain the budget challenges which are up against. And speaking of budget challenges, institutions have different pressures. Some have operating expense pressures, some have capital pressures, and when you're talking about putting a new consolidated plan together, you have to understand the sort of the differences, in building and designing a process to be able to handle what the financial side of the house, the CFO, is looking to achieve. Next slide. And so if you look at a master plan, there are multiple blocks that need to be done. And I always like to say, really what this is about is doing your homework. There are a lot of stakeholders. There's a lot of sort of social engineering that has to go on here in getting multiple stakeholders to realize that they can take a utility computing approach. They can set up a facility and share assets, both internally and external partners. I have several institutional clients who have rebuilt in the last couple of years in the consolidated groups, and they have third parties that they work with externally who have come in and they're hosting them on their prem, and it's worked out very well, and it's actually turned out to be a reasonable revenue stream for them to be able to cover some of their costs. Working with multiple organizations that have sort of competing and different priorities and profiles can be extremely difficult. And I tend to find that it's sometimes those kinds of issues that prevent a fairly cohesive master plan from being put together. And yet almost all of those can be overcome if the right kinds of discussions are fostered. One of the most difficult things at the institutional level is to come up with a really good comprehensive understanding of what you have. The assets that you have, where are they? What are you consuming? What's the total budget cost? What do the inventories look like? What is the university or what is the college hosting large scale? Everybody knows about, some of the major facilities, but what tends to be, next slide, lost in the fold is what I call the sort of hidden server room and sort of rogue HPC capabilities. This is just a slide of a recent client that we did in terms of the interviews and the material that we had to go gather with them in a collaborative environment through multiple groups and multiple organizations to be able to find all of the HPC assets that could be consolidated. And so just hunting through the server rooms alone that were on campus and understanding whether or not they housed high performance versus academic or administrative computing assets seemed to be an easy task. It actually turned out to be somewhat difficult, but we were able to get it done. And the university itself was sort of surprised at how much assets they had that they were supporting that weren't necessarily tagged as high performance compute. In the existing data centers, it's sort of fairly well known about what departmental computing is in there and the major application levels, but there was not a lot of cross-level cross-discussion with the larger user groups to understand what their planning was, what their IT architecture changes were going to be, what their application portfolio changes were going to be, all the things that said, what's going to happen in the next couple of years, and how are we going to be able to provide a consolidated facility or continue to provide services to you. It's this sort of exercise in understanding what the forecasted requirements would be collectively that is sort of the key to the kingdom, and it almost always turns out to be surprising, and not necessarily because it's large. It turns out to be something huge. In many instances, it turns out to be more than people understood, but when you begin to factor in changes in IT architectures, reducing their physical size, sort of efficiencies of moving some applications to the cloud, some of that can be blunted. So the forecasting is not necessarily there to be able to produce a larger sort of epic requirement to move forward with. Next slide. And so we talk about modeling, and this is really nothing new here, but this is something which is not necessarily done, at the institutional level, where all the assets are combined and we understand what the platforms are and they're categorized, and we understand the segregation requirements, and we produce a series of models that show over multiple years exactly what the impacts would be for a lot of things, mostly new architectures. That turns out to be one of the more difficult things to crack, since most of the hardware that people are bringing in is, fairly dense and consumes a lot of power, and there isn't necessarily reasonably good roadmaps that go out more than 3 or 4 years that you can rely on from the major HPC competitors, but still it can be modeled in a sort of good, better, best, situation. If there's one caution that I can give you, is that a lot of times we have edges approaching this using a spreadsheet approach, and that turns out to sort of design a facility that's much larger than is absolutely necessary. Understanding what the actual power consumptions are for equipment at the rated capacities and what the impacts are of a sort of a sine wave of power consumption during the course of a day or a week or a month is really critical to putting together a good cohesive model to understand what you need, not too much, not too little, but to be able to handle some degree of change. Next slide. And, if you put a master plan together, you're essentially doing scenario analysis, where you take the capacity information, changes in architecture, a lot of non-technical constraints that colleges and universities have, and a bunch of solution alternatives, and you create a series of scenarios. I'm not going to illustrate many scenarios here, but it's the creation of multiple scenarios in the sort of, the collective consciousness that begins to get the community to understand that there are multiple ways to solve the problem. And, that's when having non-standard approaches, like the one that Raul is going to talk about very shortly, becomes a critical element, because it allows you to understand the impact, next slide please, of how each of these scenarios has, in terms of the technology and the facilities, effect on OPEX and CAPEX. Budget is probably a better word. And coincidentally, one of the curiosities is that in looking at a scenario and its cost and plotting it out over a 1, 3, 5, 10-year period is useful only if you understand it in the context of how much you're spending now. And for the most part, we have found that many institutions do not have a really good, solid understanding of what their total costs are, and they are surprised when a little forensic financial analysis is done. And part of that is because when you're doing the modeling work, previous slides, and you're understanding how much HPC hardware is out there and who's doing it, it's not evident how those budgets are being allocated. They're generally stovepiped. When you begin to pull that information together, it's sometimes a little shocking to see what the overall costs are, and it becomes less difficult over a multi-year period to say, we can't afford to consolidate, we can't afford to rebuild, we can't afford to have a custom solution done, because we already have a fairly significant cash flow supporting this. And that's sometimes when the issue of non-HPC coming along can help in measuring that investment. Next slide. And what is also sometimes not looked at is not just those scenario budgets, but what the total cost of implementation would be. And there are collateral projects which come along with any of these kinds of changes. And if I had to leave you with a couple of thoughts here today, it's the more you understand the financial environment, the more you're able to command well thought out and well researched data and present that back, the lower the risk factors seem to be, the more open folks are for change. And in gathering that data, you tend to build a coalition of people who help supply it, and it's easier for you to go, sell this, concept internally as a collective rather than, every group and every stovepipe doing it themselves. Next slide. Yeah, and this is a good slide to shoot to, because this is just an example. The names have been changed to protect the innocent of, the costs for doing these kinds of projects move throughout multiple projects and have to be consolidated and brought forth as a program. So in this instance, this was for an actual university client. We were looking at all the collateral projects and had to ring them together, because if you're talking about reducing costs in an existing facility by using the adoption of cloud, you sort of then have to understand what that cloud adoption and transformation costs are going to be and include that, because wherever the application, wherever the workload goes, there is a cost. And pulling multiple budgets together from multiple moving parts in this kind of change management can be daunting, but it also helps you understand how big the issue is. Next slide. Go to the last slide. Next slide. So how is success measured? And before I turn this over to Rahul, curiously enough, it's rare that I see a master plan have an issue based on its technical aspects when you're discussing this in a community. It's easy for us to come up with the technical solutions. We all sort of understand that. The harder part is expressing that to the institution, that technical solution, in terms of what its intermediate and long-range budget effect is going to be. And the only way you can do that in doing this kind of scenario analysis is to do your homework and do the background work and do the financial work. And so I often say that your technical architects, your HPC architects are extremely important, but don't forget your financial analysts, the folks that you have to work with to be able to put costs and time and risk together on this. And other points are, these things are not big bangs. They're phased over numbers of years. And what I tend to witness in working in a lot of institutions is this feeling that we're going to do this all at once, rather than do it as a phased approach over numbers of years and being able to control risk. And also, flexibility and control are really key elements. If things change, how does that master plan adapt without serious financial impact or risk impact? These are all parts of what a good master plan is for high performance computing when you're going to consolidate, or for that matter, any other kind of computing. I'm going to turn this over to Rahul now, and Rahul, take it away.
Thank you, Kevin, and thank you for the informative presentation. Good afternoon or good morning, everyone. I am Raul Martinek. I'm the CEO of DataBank. Damien, I'll let you continue to have control, and we'll just, if you could just move the slide forward. Great. So what I wanted to cover today was just give you a brief overview of who DataBank is and some of the groups of companies we're associated with, tell you about what we're seeing in the marketplace with HPC, and then most interestingly, kind of give you the details of a project and a partnership that we did with Georgia Tech to kind of enable their efforts on the HPC side. Next slide, please. Keep going. All right, so who is DataBank? DataBank, we are a national data center and managed services company. We were started in 2015 in Dallas, and since then have grown from a single data center in one market to 19 data centers in 9 US markets. We're very well capitalized with a leading investor group in DigitalBridge, which I'll give you an overview of on the next slide. We have over 1,300 customers and kind of a broad product offering. Next slide, please. This gives you an overview of our data center footprint in the United States. We have 19 data centers in 9 markets. At this point, actually over 50 megawatts of installed UPS capacity and 500,000 square feet of raised floor. That gives us a kind of broad perspective on the different use cases for infrastructure inside data centers, including HPC. Next slide, please. Fundamentally, though, what we do is, we finance data centers, we build data centers, and then we operate them. As you guys are well aware, data center infrastructure is extremely expensive. Kind of the numbers that we use on average is about 10 million per megawatt. So obviously, given the power demands of HPC and the cooling demands of those types of environments, those figures can escalate rapidly. And what we've tried to do is come up with a model that allows us to partner with universities to kind of get the critical colocation infrastructure that they need to run HPC environments and allow DataBank to be their partner. Next slide, please. You can keep going. Well, Kevin covered most of this. I'll just give you a couple examples. We're seeing, high performance computing clusters appear in our data centers. They obviously have, specific power density and cooling requirements. Most of this is either, NVIDIA DGX type systems or other systems. Obviously, that entails significant networking infrastructure to make those clusters work. And ultimately, we see them in a number of areas, including artificial intelligence and machine learning, IoT, and biomedical research. Next slide, please. This is just another slide which I just covered. We can actually move on. Thank you. And ultimately, just a little breakout of a cluster. Obviously, when we think about it, we need obviously available land to build these facilities. You need to kind of fit out the data center with the requisite mechanical and electrical systems. And then ultimately, we need to be able to support those environments either with air cooling or liquid cooling and deliver the right amount of power. Next slide, please. Next slide, please. Just very quick on DataBank and our partnership with the education community. We've been working very closely with the supercomputing sponsors. Actually, last year at an event, the supercomputing event in Dallas, we were able to partner with Learn, which is the Internet 2 network, and deliver kind of the first 400 gigabit Ethernet link traversed over a metro distance of 9 miles. And it's just kind of part of our continuing efforts to understand and support the education community. Next slide, please. Here's an example of some of the universities and colleges that we continue to work with from a co-location perspective, from a managed services perspective, and even with some cloud and content. We've had a long experience with the education community. Next slide, please. Next slide. So this is where I'd like to spend a little more time and tell you about our partnership with Georgia Tech. It was something that was really a vision of the university where they were looking to kind of create not just a data center footprint to support HPC needs, but really kind of an ecosystem to foster collaboration between the university, governmental agencies, and the private sector. Ultimately, with the university that we speak to, we know that budgets are always under constraint, that there's a lot of demands for different projects, and that ultimately, as Kevin had pointed out in the previous slides, there's a lot of knowledge that goes into how to properly size, support, and maintain data center infrastructure. So we were trying to come up with a program that would allow DataBank to, do what it does good, which is finance, build, and operate data centers, and allow the university to capture the current spending that it has with data centers and turn that into a new solution that supports their needs today and into the future. Next slide, please. With Georgia Tech, the project was called CODA. It was a combination of a 650,000 square foot office tower that was built by another developer, and then an 88,000 square foot data center that was built by DataBank. The whole project was a collaboration to, again, create this ecosystem where the faculty and the students of the university could collaborate with interested third parties that want to leverage the knowledge and the capabilities of that university. Next step. Next slide, please. Ultimately, what the makeup of the arrangement was that DataBank, that Georgia Tech would provide a 99-year air rights lease to allow DataBank to build the data center. We worked very closely with the folks within Georgia Tech to design the data center and came up with a rather unique design where we had two different power systems in the data center. As you know, with HPC, redundancy is not as great of a concern, so we were able to design a power system that had a large amount of single N power, but then for the more sensitive databases and other workloads that require redundancy, also have a 2N system. So we were able to kind of build two power systems within the data center to accommodate these disparate needs. In Georgia Tech's case, they had a plethora of on-site data center campuses and some leased data center campuses. And working with them closely, we were able to kind of size the amount of that spend and then translate that into a 2 megawatt lease. So this is money that the university was already spending today, but we were able to kind of use that spend, couple that with obviously the great credit quality that a client like Georgia Tech has, which allows DataBank to then be able to finance that data center over a very long period of time. Since we built the facility and because of the unique assets that are in it, the supercomputing cluster, the petabyte databases that support some leading edge research in the space, we've had a whole number of other folks that are interested in kind of partnering with Georgia Tech, express an interest in not only leasing office space in the tower, but also taking space on the data center floor. And we think that's just a tremendous partnership because it allows the university to obviously focus on what it's trying to accomplish, which is to be able to have the infrastructure in place to be able to expand their HPC and their data analytics and advanced research efforts, and then allow DataBank to build and operate a data center in the most economical manner, and then to leverage our ability to bring other tenants to that data center to bring the cost of the project down so that it can be viable from an economic perspective. Next slide, please. There's two pictures of the data center there on the left. It's a 4-story facility with 3 floors of raised floor and 1 floor of mechanical and some underground common areas. And then on the right there, you see the black office tower, which is the 650,000 square foot office tower of which the university became an anchor tenant in that facility. And about 50% of it is being leased to third parties that have an interest in collaborating with the university on these types of efforts. And I think with that, that's the end of my presentation.
Thank you, Raul. Great presentation. Same to Kevin. Thank you for making this happen. We're going to move to questions. You can write your question in the chat room, or also you can unmute your line and ask and go ahead and ask the question. In the other chat room, we have 2 simultaneous chat rooms. In the other chat room, we receive a question, a couple of questions. So let's start with Kevin. If you develop an HPC consolidation plan and place it into a single facility, how do you handle federal regulatory or grant security requirements?
Oh, interesting question. Yeah, it can be an issue if it's not understood in advance. So depending upon it, we're not going to go through all the different levels of federal security requirements. There are many of them. Understanding, as we talked about before, the sort of model going forward in what the requirements are allows you to identify those security requirements that are permanent and long-standing. Those may require physical separation, so we call that cage within a cage. And in many instances, when we design out an HPC floor, there is a segment of that floor which, and while the whole facility is, is segmented within the floor, that section is segmented from the rest of the rows. Additionally, we can secure all the communications links in and out of either the entire facility or just that single segment back into the provider's Meet Me location or within your own Meet Me location, so that those adhere to the sort of lower level standard federal requirements. If in many instances we have HIPAA requirements because the HPC facility houses both sort of standard academic HPC, but the institution may have a medical facility associated with it. Extremely common. We have multiple clients that have done that, and so we have to segment the facility and create some separation in order to solve for HIPAA requirements. Additionally, if you have grants, and many research institutions have grants from companies that have requirements for either IP protection or FDA protection if they're working with cohorts for drug studies, as either embedded within the medical facility HPC requirement or just as a standalone, you can segment those two. So the key to the answer to that question is understanding the application portfolios you're bringing in, understanding that you have to design the layout of the HPC facility so that it meets the requirements. And then actually meeting the requirements is not necessarily difficult. You may have to get certain certifications. Those can take time. We have specialists, both Raul and I understand that process in terms of how you would get those levels of certifications. It can take a little bit of time to get done, but it's not impossible. We've virtually never ran into a situation where we could not provide the necessary isolation. And I strongly suggest that when you look at building a facility, you do look at it as multi-use. Because in many instances, some of those security requirements can evaporate over a period of time. Project is done, the requirement goes away, and now you can take that space and return it into general purpose computing. So that's the point about flexibility. When all these things are isolated, if you lose one, the pieces of the pie are separate and you can't reconstitute it.
Thank you,
Good
Kevin. Raul?
Yeah, if I could add to that, Kevin, that's a great question. I mean, security and compliance obviously are two areas that are very much of focus in today's world. At DataBank, we have a lot of emphasis on that. From a pure physical security perspective, and looking at the Georgia Tech data center, some of the unique requirements we had to satisfy there was, the connectivity coming in from the street into the Meet Me rooms and to the Georgia Tech data center hall. Those had to be kind of in separate physical conduits with auditable, draw traps. Once you've kind of managed the physical security, then there's the whole compliance regime on top of it. At DataBank, we've been able to achieve up to FedRAMP compliance capabilities. So, as you know, there's different levels of NIST compliance regimes, and we're able to kind of work with our partners to help them go through those, to attain those compliance certifications. So, all the data centers that we operate are either SSE 18, HIPAA High Tech, PCI DSS, or FedRAMP compliant. So it's important to understand the compliance requirements that the environment are going to need to support, and then be able to work with a partner that can implement, the physical and logical security controls to help achieve those compliance certifications.
Thank you. Great answers. Raul, what are the biggest challenges that you see to a university implementing an HPC strategy?
Okay, great question. We regularly dialogue with the university community to understand, where they are on their kind of digital transformation strategy and kind of their adoption of HPC initiatives. It's quite a wide range of options there and journeys, as you can imagine. I mean, ultimately, what we see is there's a general desire to kind of be able to have this type of capability, but that there's a lot of different priorities within these universities around, do we focus on what lab environments? Do we focus more on computational research? How do we separate out kind of the internal demands from, from kind of future demands? And ultimately, I think it speaks to Kevin's initial presentation, where it requires a real kind of sit down and a thoughtful inspection and analysis of, all the activities that are happening in the university that could become part of the solution to, an HPC environment, and then being able to have a roadmap that, reflects, what's realistic in terms of what's currently being, spent, and where that can go into the future. So there is, I think it's more, the biggest hurdle we see is just kind of a focus around wanting to solve that. There are obviously a lot of folks that have already solved that, so we know it can happen. And obviously, we're happy to kind of share the Georgia Tech example as one successful avenue to do that, while there's many others.
Thank you. Kevin, do you want to add something to it?
I think Raul pretty much nailed that. I think the only thing I would add is there's a requirement in this to understand the sort of the way you finance a strategy. We talked about this a little bit, and Raul touched on it in his answer. And I tend to find that large commercial enterprises, are driven by the finance groups. They understand where cash flows are and how to control it. Colleges and universities tend not to be that. They're stovepipe. Their budgets are independent to each other. It's not necessarily a natural process to understand how you would combine budgets to meet a strategy, a collective strategy requirement. More importantly, how you handle even minor issues like chargeback and cost allocation. And while this seems sort of silly to talk about in the era of solving complex problems in large data sets via high performance computing, it is always amazing to me that it still becomes an issue. It has a lot to do with the sort of the history and the culture of an educational institution and how they fund research and how people are able to operate freely, and this is all good things. But the whole concepts of how you handle the financing and budgets and cost allocation and the potential for chargeback and usage costs, these are all things that institutions need to sort of struggle over a little bit to decide how they're going to manage mechanically these new facilities. It can be done. Georgia Tech did it. We have dozens of other universities we work with that did it. But curiously enough, it takes a bit of time because it's a change in culture, and the culture ultimately is responsible for making the strategy successful.
Thank you, Kevin. One question for Kevin. You spoke about Moore's Law, and now the question is specifically about cooling methodology. We understand that it's becoming an issue, especially for today and for the future, with the exponential growth of processing power and consumption of energy. With HPC, do you supply chilled water, and at what temperature, and what do you see as a solution for HPC when it comes to cooling?
So, this is the heart of HPC at this point, and it's it's a sort of foundational question. When we do the modeling exercises we talked about earlier, and we look at the architectures that people have deployed, we've moved from the sort of 15 kW per rack to 30 up to 60. A lot of it is highly dependent, your requirement, on the HPC architecture you're going to employ, and I will tell you that there still is a lot of life left in air-cool. We have clients right now that are fitting out facilities, and their average is pushing 30 to 35 kW per rack, but they have certain racks and row sections that are pushing 50 to 60, and with hot aisle containment and front of cab boosters, blah blah blah, you can engineer a solution that allows you to get by on air cool. That, however, is going to start to become less and less long term an option, and so we urge folks that when they're putting these things together, and we're designing a data center, that we make sure that the facility has the capability of bringing what I'm referring to as fluid cooled, because it's not always water, but it is more common to use the chiller loop in water cooling, or to segment the existing chilling loop for water cooling and bring it out to the rack. We don't have the time for that lecture, but you can build a physical facility, arrange to have proximity to the cooling lines, build the valving and stubs in so that you can then deploy it later, and then build that out. It is entirely dependent, and I'm going to go back to the first discussion, on your forecast. And the forecast looks at IT architecture. It looks at power density. And if it turns out that near term power density is high, you probably want to engineer it from day one and spend the capital. If it looks like it's speculative, meaning we think we may need it in years 4 or 5 or 6, you may want to be in a situation where you spend some small capital to be ready for it, but not deploy all the cost to begin with. Lots of our clients will design a row or more specifically to be water cooled, bring a lot of the infrastructure in, cap it off, and not use it until they need it. So this is part of the discussion. This is part of the modeling exercise to understand where you need it. And any good modern facility provider should be able to provide it for you. And I know that Raul can in his implementations, because they essentially pander to HPC and understand the impact of water cooling.
Yeah, Kevin, great response. And just to add to that, so from a kind of our experiences, across our footprint, we see a lot of high density workloads. Agree with you that, up to 20, 25 kW airside cooling methods are still very efficient, in addition to, chimney cabinets and the hot aisle containment or cold aisle containment allow you to kind of comfortably get into that range. With Georgia Tech, their current requirements were in the 30 kW per rack, so they could have gone with kind of an enhanced air cooling technique, but they had a desire to move much higher than that. We ultimately settled on a chilled rear door solution that we have tested as high as 100 kW per cabinet. So obviously, that's quite an extreme version of that, but certainly future-proofs the solution so that as these HPC kind of form factors get continually dense, we won't have to do anything with the data center floor. So we were also able to, again, back to my earlier point, kind of combine that with, lower density cooling options on the same data center hall. So it's really a function of, spending a lot of time thinking about your roadmap and then picking an engineering solution that allows you to be flexible depending on what happens in the future.
Thank you. Great answer, Raul. What factors are important in considering what size data center a university would desire?
Yeah, we see, ultimately we start, and that's part of the analysis that Kevin had talked about, and EYP and DataBank have had a number of these kind of seminars with universities where we kind of try to help define that. As a baseline, we start by trying to understand, what's the existing critical load that a university is consuming across its entire footprint. And that's where that kind of coordination is important, because as we know, there's a lot of shadow IT happening in enterprises and in universities. And ultimately, to get the most efficient design, you want to be able to aggregate the greatest amount of demand. So we think that's kind of the initial baseline, and then couple that with the types of workloads, and then really what is the vision of the university in terms of what they're trying to accomplish. Are they looking to bid on larger kind of government grants that require certain kind of footprint and to be successful to get those grants? Are they looking to partner with to attract more researchers, and what do those kind of pods look like? So it's those types of factors that we look at in consultation with the university, and then come up with a scalable and modular design. I mean, the good news about the way data centers are built today is you don't have to deploy all the capital up front to have the runway to expand. I mean, our modular techniques have gotten where You obviously have to build the building shell and all the common areas, all the power infrastructure, the initial power infrastructure, but the white floor and then the power and the cooling for that white floor, that can be chunked out in a way where you can delay the most expensive pieces until you actually need it. So there's a way to kind of be able to have a lot of runway, but not have to spend a lot of dollars up front. And those are the types of thinking that we bring to the table when we're looking at this.
Thank you, Raul. Kevin, is there a loss of capability in the computer if the computer facility moves off campus?
This is one of those questions that is consistently asked, when we're talking about options of where to place it. So it really, again, it depends upon the mission of that HPC center. Because you're dealing in an education institution, there is a lot of, sort of efficacy, particularly from a curriculum standpoint, to have ready and easy access to an HPC facility for students as they're learning. Although it is far less hands-on necessarily than it used to be. In many instances, a lot of early on curricula doesn't even require any entry into the existing facility. You're really just doing console work. But there are some folks who want to get in there and get their hands dirty and build the systems themselves and test them and understand them. The folks that are more hardware oriented in the space. And so we often talk about having a sort of a hybrid solution where you retain some small amount of HPC to support core curricula on the campus, and you think of that more as a laboratory environment, and you build that out as a front end to the larger HPC facility, which can either be retained on campus or can be moved off campus. I have generally found that if the facility is within a certain number of miles from the main core campus, that it does not have a material effect on curricula or on use. It can have an effect on the network costs, incidentally, because you're dealing in some bloody big pipes to be able to support this stuff and where you need to go. Although in some instances, moving the data center closer to access to those to large-scale fiber high bandwidth capacity can reduce your network costs. But ultimately, if you move too far away and you've got to backhaul a lot of stuff into the campus, it can cost. There's some offset there. So the generic answer is we haven't found, although I'm sure there is some small, a great loss. We have found that consolidated facility, something new and larger, has significantly greater benefit because just by increasing the cores, you're decreasing runtimes, increasing availability of systems. People don't have to wait as long to have their jobs run. I mean, there's this whole environmental thing that pops out too, which says if you're moving into a new facility, and most universities now have some kind of monitor and tracking for environmental use, you're into something which is infinitely more efficient. You're, participating in the sort of, greening of what would otherwise be something that consumes a lot of power. You're certainly not offsetting it, but you're making it better, and that's certainly good for the environment. Sometimes difficult to do on campus because of the complex engineering that would be required, but nonetheless it can be done, and particularly the way that Raul DataBank did it, was very interesting. So no, I am no longer in the camp of the folks that like to tree hug and be able to, kick it under their desk or walk down the, walk down the road. The problem is you do have support staffs, and so there is a human factor side that you need to work in. You have to understand that if you are going to staff that facility still, and people need to have access to it, part of that plan, the collateral projects need to understand how you move your staffs, how they're going to get back and forth from a transportation environment, that the facility is built to be able to give them some office space and lab and breakdown and testing facility, that you have swing space in order for them to build and operate in. And so that can sometimes be lost in the shuffle, and it shouldn't be, because it goes to the sort of healthy environment for academic computing.
Thank you, Kevin. Raul, do you want to add something to this question? Raul, I think you're on mute. Okay.
Oh, I apologize. No, I have nothing to add. Good response, Kevin.
All right. So last question for Raul. Since you talk to many universities, what would you say is the overall stage of universities adopting this type of strategy?
That's a great question. Our conversations are that it's still very much in the infancy. That most universities are transitioning towards kind of computational research initiatives and HPC initiatives. Obviously, it's new technology for everyone, and interestingly, we think it's the same. It reflects kind of the state of the enterprise market. When we look at what's going on in our data centers today, we see obviously a smattering of these HPC deployments, but they're by no means the majority. And we think that kind of with the advent of the new technologies that Kevin talked about, things obviously like machine learning and artificial intelligence and deep data analytics, that this is going to be kind of common capability that all enterprises and all universities, are utilizing. So still feels like it's very early innings, but what's great is, people are really spending a lot of time thinking about it and thinking about how they can kind of incorporate that into their roadmap.
Thank you very much. I would like to